When you talk about unstructured data and then curating it in a cloud environment, I think you're talking about two very different things. In many cases, you don't want to, quote, curate the data and store. What you want is to be able to go back to the original form. So you want to keep the unstructured data. You want to then be able to process it and use it, right? But retain it in its original form. That's one of the reasons for the concept of big data, is that you're able to keep large amounts of data in its original form, process it. So you may use whatever types of analytic and algorithmic techniques to validate it, whether it's a sampling model or just a cleansing model, right, where you're taking that data and using a curated data source in order to validate it. So for example, location's a great example of this. If you have disparate kinds of unstructured data coming in, and some has a lat long, some has from a sensor, and some has an address from a shopping cart, and some has a descriptive phrase from a tweet, but you want to be able to associate that to get a picture of what's happening in a particular area, right? Purchasing patterns, where people, population movement, that type of thing. You can use location to take those three very different ways of describing a location, apply it to a curated data source, a gazetteer of some sort, and then understand that they're all talking about the same place or the same thing, right? But you can then, if you wish, store it off as a curated result, right? It's now been validated, cleansed, stored. But by being able to keep the original source data, when you get more information, you can retest, you can see changes in trends, etc., without having to throw away the original data. It's a very important element in big data analytics. It adds a new dimension to the information that you have. Those of us in the geospace know about some of the early projects like CitySense. I think that was probably 10 years ago, maybe not quite, where you could understand population movement based on the demographic of the user, what was happening at certain times of day, what communities were going from place to place. It's this type of sentiment, this type of crowdsourced data can give us a tremendous understanding of what's occurring in various places and what the sentiment of marketplace may be. Again, population movement, population behavior. So I think it's a very important contributing factor. The relationship between big data and geospatial technology is extremely intimate. Location is part of almost every sensor reading, every tweet, every web transaction. It's there, it's assumed, and it's just part of the context in which this type of big data is occurring. I mean, some people, when they talk about big data, they mean large amounts of data. Okay. From one perspective, the big data technologies are valuable in doing just parallel processing. So if you have a lot of raster data and you want to cleanse it or do a large-scale point and poly in a batch model mode, that's great. The technologies work for that. But generally, when people are referring to big data, it's not just large amounts of data. It is this social data. It's this information that's coming from the cloud, from sensors, from social networks, from IoT. And location is just assumed. So once you have so much information that is already geotagged and georeferenced, the initial use cases have been, from a geo perspective, relatively coarse. We do very simple things. We do pins on a map, we do clustering, right? We aggregate based on location. But Having such a rich set of geographic information means that we can do very sophisticated geoprocessing on this data if we learn to work with it in its form. If we don't think, oh, now if I can just structure it in a geospatial structure, I can work with it. No, if we can enable the geospatial analytics to be performed on the data, regardless of the structure that it originally comes in, then there's a huge opportunity for advanced geospatial processing on this information.